Hello and good morning dear students. So today is 31st of July 2020. Yesterday I have given properties of definite integral. So today I am starting with one of the properties and its sums. Okay. So the property that I am starting is, which is a very important property, I have told you yesterday also, P4, property number 4. P4, the property is integration 0 to a fx dx is equals to integration 0 to a f of a minus x dx. Now if I have to use this property, then the lower limit has to be 0. The lower limit has to start from 0. 0 to a fx dx is equals to 0 to a f of a minus x. So I hope you have learned this property. So today I am only going to focus on this property and its sums. Okay? Now come back to exercise 8.18. And the question we are starting with is question number 19. Now please mark those questions which we are doing. Question number 19. This question has already come in 2014. The question says integrate 0 to pi by 2. This is the function given to us, sin x divided by sin x plus cos x root. Okay. Now if you can see out here, it's starting from 0 to pi by 2. That is 0 to a. So hence if you compare, then what is my lower limit? 0. What is my upper limit? Pi by 2. What is the value for fx? This whole is the value for fx. And the question is telling you to evaluate. Okay, so we start with the assumption always. Let capital I is equals to 0 to pi by 2 sin x divided by root sin x plus root cos x d, which is the given integral. Let us assume this given integral is capital I and give this as equation number 1. Okay. Now what we are doing is, since the limit is from 0 to pi by 2, now I can use property number 4 out here. Okay, if I write down by, or we use P4 here. We use P4 here. Therefore, what becomes after using, or what we get after using P4 is, this integral I becomes integration 0 to a remains as 0 to a, so it remains as 0 to pi by 2. 0 to pi by 2 remains as 0 to pi by 2. Remember that we are using now P4. Okay, so what does P4 tells you? Limits as it is, but wherever it is x, the function also same, the function also remains same, but wherever it is x, x changes from x to a minus x. So x will change from, the function is same, x will change from x to upper limit minus x, that is pi by 2 minus x. Please see out here, what is the upper limit? A. So x changes from a minus x, x to a minus x. So x changes from x to pi by 2 minus x everywhere. Okay, here x will change, here x will change, as well as here also x will change. So therefore we will be getting sin, in place of x I'll write pi by 2 minus x plus cos pi by 2 minus x. Once again I am repeating. Okay, when we are using property number 4, or sums doing on property number 4, the first step, whatever is given in the question, assume it as capital I. Okay, assume it as capital I. Now what you do is we use, or you can also write by property 4, or we use property 4. Then after that what we get is capital I is capital I. 0 to pi by 2 remains as 0 to pi by 2 since it is 0 to a. Okay. Function also same. The same function will be out here. This is the function, the same function out here. The changes will be only in x. X will change from x to upper limit minus x. X will change from x to upper limit minus x. That is pi by 2 is upper limit, pi by 2 minus x, pi by 2 minus x, pi by 2 minus x. I hope you are clear with this. Pause the video till here and note it down. Okay, I hope you are clear. Now, upper limit minus x. Now, what is the formula? Sin 90 minus x, cos x. Sin 90 minus x, cos x. Cos 90 minus x is, cos 90 minus x is sin x. Okay, complement triangles, which we have learned in class 9. The same formula I am using out here. Sin 90 minus x, cos x. Sin 90 minus x, cos x. Cos 90 minus x is sin x. This was equation number 1. This will be equation number 2. Okay. Now what we see from equation number 1 and equation number 2 is limit is same, root sin x, root cos x, denominator is same. Okay. So this is another important step when we do property 4. The moment you put the limit, you'll be getting two equations, equation 1, equation number 2. This part is very important. Now what we'll do is we always have to add equation number 1 and equation number 2. So what we'll do? Adding equation 1 and 2. Pause the video and write down adding equation 1, equation 2. Okay, so now after that step, what we'll do is adding equation 1 and equation number 2. Now I hope you know what is equation number 1 and equation number 2. Now when we add equation 1 and 2, addition goes left hand side, right hand side, right hand side. Okay, so left hand side we have I, so I plus I becomes 2I, and right hand side plus right hand side. Okay, now 2I is equals to, what you can see common out here is integration 0 to pi by 2 and dx is common. Integration 0 to pi by 2 dx, integration 0 to pi by 2 dx. So I can take that common. So if I do that common part, the inside function will be root sin x divided by root sin x plus cos x, root cos x divided by root cos x plus root sin x. Inside this box bracket, can I take the LCM? The moment I take the LCM, the numerator and denominator becomes same, isn't it? The moment I take the LCM, the numerator and denominator will be same. That is, I'll be getting root sin x plus root cos x. See, this is the LCM, root sin x plus root cos x. Numerator also will be root sin x plus root cos x. Okay, so what happens? Everything gets cancelled out. Pause the video and note it down. Alright, so here this and this gets cancelled out. So what is left out is 2I is equals to 0 to pi by 2 dx. You know, integration x, pi by 2 minus 0, so I equals to pi by 4. So this is how we have to do problems based on property number 4 if the limit is starting from 0 to a. The first thing, assumption. Second thing, put the property. The moment you do that, you'll be getting two equations, the first and this second equation, and then step 3 is to add these two equations and then to evaluate. Everything gets cancelled out. So simple and easy. We move to the next question of this property. Okay, let's move ahead. Question number 18 part 2. Number 18 part 2 is integration 0 to pi by 2 dx divided by 1 plus root cot x dx. Again, the same thing. The limit is starting from 0, so 0 to pi by 2. No doubt we have to use property number 4 out here. Okay, but let's see what we can do more. Okay, so the first step again is the assumption. Assume this whole integral as capital I, as this. Now, to make it more things easy, I will not use directly my property 4 out here. Instead, I'll change what is cot? Cos by sin, is it? So hence I can write this as 0 to pi by 2 dx divided by 1 plus root cos x divided by root over sin x dx. Okay, take the LCM. Therefore, I'll be getting 0 to pi by 2 root over sin x divided by root over sin x plus root over cos x dx. I hope you are clear. Same question we have done in question number 18 part 1, right? Same question, 18 part 1, the previous question. Okay, only the changes was to change this cot cos to sin. Give this equation number 1. Now you know what to do. Put the limits, put this property, use this property out here, use property 4. The moment you use property 4, you get another equation, add these two equations, it gets cancelled out, problem is solved. Okay, we move to the next one. Now as we move ahead, you will be getting a similar type of question. 19 part 1, 19 part 2 we have done, right? 19 part 3, 19 part 4, 19 part 5, 19 part 6, same question. The answers will also be same. In fact, all the answers I believe will be 1 by 4, 1 by 4, 1 by 4. Okay, so I'm going to do this as the last sum from question number 19. The rest you'll have to complete it yourself. Okay, so we know the first step what to do. The first step is to assume the given integral as capital I. Let us keep it as equation number 1. Now use, okay, I'll just pause the video and then I'll explain you the steps. Okay, let's continue from out here. So the first step was to assume the given integral as capital I. I hope you're clear. Now what is the second step? The second step is to use the property. Okay, so by property 4, wherever it is x changes from x to a minus x, upper limit minus x. By the way, what is the upper limit? What is the lower limit? 0. So the property tells us wherever it is x, it changes from x to upper limit minus x. Wherever it is x, it changes from x to upper limit minus x. Everything remains same, to the power 5, to the power 5, to the power 5. Cos, 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 sin, sin remains as it is, but wherever it is x, the value for x changes from upper limit minus x. Pi by 2 minus x, pi by 2 minus x, pi by 2 minus x. By the way, what is cos of pi by 2 minus x? Don't go with the power. What is cos of pi by 2 minus x? Sin x. So sin x to the power 5, sin x to the power 5, and the sine of 90 minus 6 is cos 6 to the power 5, which is equation number 2. Now I hope you can guess what to do. Adding equation 1, equation number 2, you can see the denominator is same. Denominator is same, so while you take the LCM, this will be same. Numerator is also same. Everything gets cancelled out. We are done. Okay, now I'm going to show that part. So write down adding 1 and 2, adding equation 1 and 2. Alright, so therefore, adding equation 1 and 2, the same process, adding and taking the common. I hope you can guess out here. Integration 0 to pi to this into dx is equation 1, and integration this is equation 2. So adding them together, by the way, left hand side becomes 2i. You can see the LCM. The LCM is the same expression, cos to the power 5x plus sine to the power 5x, the same thing out here. Numerator becomes same, they gets cancelled out, so the remainder is 1 out here. So integration dx is x, put the upper limit and lower limit, that is pi by 2 minus 0. Okay, so I is equals to pi by 4, which is the answer. Okay, so pause the video and note it down. So yeah, assignments for today will be question 19 part 2, 19 part 3, 19 part 5, 19 part 6. Everywhere the answer is 1 by 4, and the steps are also very, very same. Okay, so that's it for today. I'll see you tomorrow with another property. In fact, yes, this property also we have to do. The sums are a bit different, another type. Okay, this is the first type based on property 4. There's one more type which we'll do. We'll see that. Okay, that's it for today. I'll see you tomorrow. Practice it properly. Bye.